Okay, so for this one here, again, continuing with dividing radicals, we have to remember that there are key components to each radicals. You have the coefficients, or the numbers that are in front of the root sign. Now, this case over here, if there is no radical in front of the root, or sorry, coefficient in front of the root, then it has a coefficient of 1. So what we do is I separate the coefficients from the radical function first. So this 1 over 5 will get removed from the root. And then outside, I have, multiplied by root 4 over root 3. Second thing I'm going to do is, using the radical property, right, of n root a over n root b, and of course the n's are talking about the indexes, is equal to root n a over b. Using that process, I'm going to rewrite this radical in this form. Okay, so this is the start. Now, second thing I'm going to do is I'm going to ask myself, can this over here be simplified? Well, the answer is no. It's going to remain a fraction. And if it remains a fraction, then we must rationalize, the denominator, which means that I'm going to have to multiply both the numerator and the denominator by root 3. So before I do that, what I do is I revert this form to this form. The reason why we use this form at the beginning is because often if we can simplify it, right, and it's not a fraction, then you don't have to rationalize it. But if it remains a fraction, then you do have to rationalize it. So I'm going to rewrite it as this, 1 over 5, and then multiplied by root 4 over root 3. Okay. So now I'm going to rationalize the denominator, multiplying this by root 3. It has to be at the numerator and the denominator, because remember, we're not allowed to actually change the ratio. Now what happens is when you multiply root 3 by root 3, you end up getting the roots removed. Now at the top, if the radicands are different, then the radicands multiply by each other. So now this is going to become 1 over 5 multiplied by root 12 over 3. Okay, now it's just like multiplying a fraction. The denominators will multiply by each other, and then the numerators will multiply by each other, and that's going to leave us with root 12 over 15. And then before we finish, we see if this can simplify. So on the side, I go root 12, and that's going to be 4 and 3, and that'll break down into 2 and 2 and 3, which means that I can pull this one, the 2 is out of the root, which is going to leave me with 2 root 3. So now finally this can be simplified as 2 root 3 over 15. And then this can't be simplified anymore, nor does the denominator indeed be rationalized because the root is not there. And so the final answer is 2 root 3 over 15. Okay, so same kind of concept as the previous example, except this time we have variables, but we're going to approach it the same way. So the first thing we're going to do is we're going to separate the coefficients from the radicals. So this here, again, just like in the previous example, if there's nothing listed, this is going to have a coefficient of 1, and that's 3. So I'm going to go 1 over 3 multiplied by 15xy, over 10xy3. And again, what I'm doing here is I'm applying the property of n root a over n root b is going to be equal to 1 giant root na over b. Okay, so I'm doing that here. Now what I'm going to do is I'm going to see if I can simplify all of these as much as possible, and I'm going to do one thing at a time. So the 15 and the 10, if I divide each of these by 5, Then I can simplify this to 3 over 2. So it'll be 3 over 2. Now, the variables, again, it's just like you're dividing variables by variables. You're going to have some cancellation. So the x's here will be canceled out. And then the y's over here, I'll do that in a different color, will also be canceled out, except the one at the bottom will turn into a 2. Okay. So that'll leave us with just 3 and then y2. Now I can already see that there's a fraction over here, so I know that I'm going to have to rationalize the denominator, so I'm going to rewrite this as root 3 and then over 2y2. Now what I'm also going to do is this one here, because I can see that there's a square, I'm going to simplify it as well. So on the side here, 2y squared. Well, remember that this turns into y times y, which occurs twice, so I can actually pull it out, and that's going to be y root 2. So when I rewrite this over here, I'm going to write 1 over 3 times root 3 and then y root 2. Okay, so we're going to have to still rationalize the denominator here. And we're going to rationalize it by multiplying by the radical in the denominator, which is going to be root 2. So root 2 at the top and the bottom. And so again, keeping the 1/3 because I haven't dealt with it yet. This is going to give me root 6 over, and we're going to say it's going to be y times 2, because root 2 times root 2 is going to leave us with 2. Okay, now I can treat this as multiplying it like a fraction, so the numerators are multiplied by each other, and so will the denominators. And so 1 times root 6 is going to be root 6, and 3 times y times 2 is going to give us 6y. And so this can't be simplified any further. And so the final answer here, and I'll write it in black, is going to be root 6 over 6y.